Hi. Today we're going to be talking about 4.4 from your book. It's about modeling. Not my first career, not that type of modeling, but mathematical modeling and optimization, or optimizing different things from economics. So, like I said, we'll be modeling mathematics, looking at some different examples from economics, and figuring out how to maximize profit and minimize cost. In my opinion, modeling mathematics is probably one of the hardest things that the traditional math student can do. It seems to be something that we really struggle with, is trying to figure out. We're good at normally being given an equation and being able to plug and chug away, but actually trying to figure out how to model stuff is a little bit harder. So here's an example I'd like for you to try is, can you figure out how you would model this situation to maximize an area of a right triangle with a hypotenuse 5 centimeters long? So I'm going to have you, I know that sounds hard, but try to figure out, okay, take what you know about the area of a triangle, a right triangle, and then figure out if you could set up an equation with one variable that would let you talk about the area of this triangle, and then we'll figure out how to maximize it. So hit pause, see how you do. Okay, if I was to draw a triangle, make it a right triangle with a hypotenuse of 5 centimeters long. If I was trying to represent this with one variable, I could call one side x, and then I'd need to use Pythagorean's theorem to solve for that other side. So I'm trying to figure out, what is this unknown side over here? I'll just call it right now a, but I don't want it to be a, I want it to be in terms of x. So if I was to solve for a would equal the square root of 5 squared minus x squared. So I'm going to, instead of writing a down there, I'm going to change that to the square root of 25 minus x squared. Because now I can represent the area of this triangle by using base times height with just one variable. So area of a triangle is 1/2 base times height. So if I call this 1/2 and say that the base is x and the height is the square root of 25 minus x squared, I now have an equation for the area that I want to try to maximize. Well, I've learned that maximizing functions is the best way to maximize a function is to take the derivative of it, set it equal to 0, and that will give me my minimums and maximums. So let's give that a shot. This was a, so if I want to find a prime, it's equal to 1 first times the derivative of the second, so that would be 1/2 times, leave the inside alone. Okay, so derivative of the outside, leave the inside alone, times derivative of the inside is negative 2x. Okay, so that's first times the derivative of the second plus second times the derivative of the first will be just 1/2. 1/2 x is just 1/2. 25 minus x squared. Okay, so if I wanted to change this up a little, I would make this a negative 2x up top, or just kidding, a negative 2x squared up top, over 1/2 and 1/2 would be 4 in the denominator. The square root of 25 minus x squared plus square root of 25 minus x squared over 2. I can reduce this fraction over here to be a 1/2. Okay, so then I need common denominator, so I need to multiply the one on the right here by square root of 25 minus x squared over square root of 25 minus x squared. That should simplify this to be, let's see, those two would make a 25 minus x squared without the square root sign, because you multiply the two together. With that other one, it would just be a 25 minus 2x squared over 2 square root of 25 minus x squared. So if that's the derivative, I want to now make this derivative equal to 0, so that's where the numerator would be equal to 0. So really all I'm trying to do is set 25 minus 2x squared equal to 0, so that would be 2x squared equals 25, or x equals the square root of excuse me, 25 over 2. Should be plus or minus. So excuse me, I have a plus or minus square root of 25 over 2, which really only makes sense to have the positive one because we can't really have a negative side length. So that's equal to, well, let's see, the square root of 25 is 5 over square root 2. So I'll just simplify it to that. Okay, so this is where again, I'm trying to maximize this, so this must be where the maximum part of this function is. So I would say that the maximum area would be 5, I'll just draw my triangle again. This is 5 over 2, and this is the square root of, over root 2, of 25 minus 5 over square root of 2 squared. So my maximum area would be 1/2 times base times height I'm going to change that back to a 25 over 2. This piece of the equation, you could change it to 50 over 2 minus 25 over 2 would be 25 over 2. Square root of 25 over 2 is 5 root 2, so really it's just 1/2 times 5 over square root of 2 squared, which is equal to 25 over 4. I can't remember if this had units on it. Let's see. Centimeters, so area would be centimeters squared. So 25 over 4 centimeters square would be the maximum area I could make for that. So some steps that you might want to write down to follow in order to do these would be as followed. Number 1, read the question carefully. You have to understand the problem. You need to read the question carefully. Number 2, develop a mathematical model. Draw a picture, label, use variables, write a function. Number 3 would be to help you a lot of times if you graph the function, look at its domain. That will help you identify exactly what we're looking at. Number 4 would be identify any critical points and any endpoints. We actually didn't test any endpoints here just because common sense tells us we know, as far as this domain goes, you could have a length of 0, but that would give you an area of 0, or you could have a height of 0, which would give you an area of 0, so we didn't really test the endpoints, but it's always smart when you're trying to find your minimums and maximums of functions to test the endpoints. The 5th step would be to solve the mathematical model, and then finally you want to interpret the results. So what do these results really mean? So make sure everything needs to make sense in the end. When you check out the units, it should make sense. When you get your numbers, they should make sense for the problem. So always try to interpret the data, interpret the results that you get for each problem. Okay, moving on to economics, we want to talk about profits and how we would maximize a profit. In order to maximize a profit, the maximum profit will always be where the marginal revenue equals the marginal cost. And here is why. If we know that profit is equal to revenue minus the cost, so profit is whatever money you bring in minus the cost that it costs to produce whatever it is you're producing. That gives you the profit that you make. Okay. If we look at, alright, what is the derivative of these? These are all in terms of x, so we just write, okay, if we're trying to find the maximum profit, the derivative of that, finding that and setting it equal to 0 would give us that. So if we did p prime is equal to r prime, which we know that revenue, the derivative of revenue is marginal revenue, minus the derivative of cost is marginal cost, and we want to set this equal to 0, set that equal to 0, then we can say that r prime then must equal c prime, or marginal revenue must equal the marginal cost. So in order to find how we can maximize profit, and a lot of econ majors, when you guys go and take economics, these will be some problems that you're given, is we need to maximize our profit, so you'll have to set the marginal revenue equal to the marginal cost. So maybe you can impress your friends in college about why we do that with this little proof here of this theorem. Okay, so give this a shot, knowing that maximizing a profit, all you need to do is take the marginal revenue and set it equal to the marginal cost, and that will show you where you can maximize your profit. So hit pause, see if you can do this problem. Go. Alright, so marginal revenue equals marginal cost. So I need to find the derivative of the revenue. So revenue is equal to x squared over x squared plus 1. So r prime is equal to low d high minus high d low all over low, and marginal cost would be c prime equals derivative of the outside would be 3 times that 1/3, they would cancel, and it would just be x minus 1 squared times the derivative of the inside is just 1. So we set these equal to each other. I'm actually going to simplify this a little bit. I'm going to distribute that 2x to both just so we can maybe see if we can combine some terms here and make it easier. So that would be 2x cubed plus 2x minus that 2x cubed. That will get those two to cancel, so that will simplify that. And then the bottom we could change to, well, we'll just keep it right now as x squared plus 1 squared. So like I said, those two will cancel. This is just equal to 2x over x squared plus 1, that quantity squared. So again, marginal cost was x minus 1 squared, and that's marginal cost. Marginal revenue is 2x over x squared plus 1 squared. Excuse me. I don't think we're going to be able to solve these real nicely, so we'll just have to graph them and find their solution with our calculator. So where are these two equal is basically like saying where do these two cross. So graph those on your calculator and see what they look like. So we see that they cross at x equals 0.294 and 1.525. Okay, with x measured in thousands of units, so we know that the minimum would be at that point 294, which would be 294 units, and the maximum would be 1,525 units. So that would be the maximum profit. The minimum profit would be at that point 294. Okay, one more thing to try. We need to look at this theorem where we want to minimize the average cost. So the production level at which the average cost is smallest is the level where the average cost equals the marginal cost. Well, if we know that average cost would just be the cost function c of x divided by x, so in this case average cost would be x e to the x minus 2x squared all over x. I could factor out that x and one of those x's with that x. So the average cost, which I'm just going to write as this, is equal to just e to the x minus 2x. So when is the average cost equal to the marginal cost? Okay, so I need to find c prime of x. So first times the derivative of the second plus second times the derivative of the first minus 4x. So we will hit the minimum cost when the average is equal to the derivative of the cost, or the marginal cost. So set these two equal to each other. e to the x minus 2x equals x e to the x plus e to the x minus 4x. Okay, well I know I have an e to the x over here and an e to the x over there, so I can cancel those two. I can move over that negative 4 to make it 2x equals x e to the x. I can divide both sides by x so that I get 2 equals e to the x. So if I do the natural log there, it's just x equals the natural log of 2, which equals about 0.693. It says this is in thousands of units, so we'd say 693 units. Now I do just want to double check and make sure that this is a minimum, so we can always check the concavity of this. To check the concavity, we want it to be concave up, so we want the second derivative to be positive. So I've done the first derivative. I just need to do the second derivative of this average cost, which would be, if I wrote it as d squared of x over, or of c, sorry. Well, we'll just write it d squared over dx squared, the second derivative of the average cost, which is that c over x. So the second derivative of this, basically. If I do the first derivative, it's e to the x minus 2. The second derivative would just be e to the x. So that's equal to e to the x. That is positive the whole time, meaning that it would be concave up. So yes, that would be a minimum value there. So, like I said, this stuff's not easy. And most of what you'll practice is actually the first two examples. It's just these are two very specific and pretty neat economic examples, but really what you're going to be doing is taking situations, going through those steps of, okay, how do I figure out how to set up this problem to model the situation? So I know this is going to be hard. Bring in any questions you have from the video, and we're going to just attack these problems and practice and work hard and help each other out, and we'll make it through this. I hope you guys have a great night. Thanks. Bye.